Hello, welcome back everybody. I hope that you are suitably refreshed and ready for the next session. So we went for slightly shorter presentations, perhaps of a particularly practical nature in this second session. And we will pretty much go with the same format, which I think worked well first time round. We'll keep most of the questions and discuss them in our question and answer session at the end. But if there's a very quick one, and if time allows, I might sneak one in now and again if I've got the chance. So first up is Laura Bouvet. She is going to start us off with a talk about work that's been done under the auspices of the Innovative Farmers Group. Laura has finished her PhD a couple of years ago and since then has been working for the AHDB and Agri-Tech E. So she's part of the group that has helped to put together the Agri-Tech Week set of talks. So it's great to be able to welcome Laura to give her talk now. Over to you, Laura.
Thank you very much for the introduction, Lydia. Good morning, everybody. So for the past 2 years, as part of my work at Agri-Tech E, I've been coordinating an Innovative Farmers Field Lab, and I'll be spending the next 5 minutes giving you a snapshot of our findings. So in our field lab, farmers first got together because they wanted to find a way to make their digestate work that bit harder for them, whilst minimizing any environmental impact. And we've already heard from Ralph earlier this morning about the properties of digestate, which is, rich in readily available nitrogen, potassium, and phosphate. So what I like to focus on is the issues that can arise with application timings. So digestate is best applied when a crop is at maximum growth, and this is usually during the spring for most crops. However, farmers in the group find that they're often left with extra digestate following a spring application. So a solution would be to store that surplus until it's needed, but storage solutions are an expense. It's an investment, so it's not always an option for farmers. And if farmers have fields that are in a nitrate vulnerable zone, as Ralph also alluded to, there's restrictions.
Laura,
on... Yes?
Sorry to interrupt. Your screen isn't showing full screen. It's cut off down the bottom.
Oh, can you see it?
We can, yes, that's it. Thank you.
Sorry about that. So, as I said, there's also additional issues that can arise, and there's restrictions in application timings and concentration levels of nitrogen in those particular zones. So in this field lab, what we wanted to find out is whether cover crops could actually help with that. So we had Niab come on as a research partner. So Lydia and her team have been helping the farmers design a field trial in order to explore this question a bit further. So in the first 2 years of trials, we looked at a control treatment, a digestate only treatment, cover crop plus digestate, and cover crop only. So that was in the first 2 years of trials. And in the last year, so 2019-20, farmers also wanted to look at concentration levels of digestate in a bit more detail. So we looked at cover crop only, a control, and a combination of cover crops with a standard dose at 25 cubic meters per hectare of digestate, and another combination with a higher dose at 50 cubic meters per hectare. And the farmers involved in the trials, well, we've had up to 6 farms across all those years, with the core of farms in the east of England, and we also had a farm in Lincolnshire. So we covered different cropping systems and different soil types as well. The mixture of cover crops that we used was sourced from Cotswold seeds, and the mixture was a mixture of hardy varieties ranging in different soil structuring properties and nutrient regulating properties. So when looking at the available nitrogen in the soil, we found that the areas where digestate only had been applied showed higher levels of nitrogen leaching through the deeper layers of the soil compared to those other treatments where you had the combination with the cover crop. And we saw that across different sites. So that was really promising. You know, it showed us that the cover crops were doing a really good job at picking up that nitrogen. Now, looking at the data later on, just following on site 1, and in that trial where we were looking at the different concentration levels of digestate, what's quite interesting is that we found there was more, the data suggests that more nitrogen was being taken up when there was a higher dose of digestate applied compared to a lower dose. So that difference isn't quite significant, but it's what's really interesting, I think, is that it still shows that cover crops, you know, still has that nutrient absorption safety net in those kind of situations. So that's quite interesting. So following on with the site, with this particular site, in general, something else that farmers wanted to have a look at in this trial is what the impact of this additional nitrogen locked up in the cover crop and being absorbed would have on the following cash crop. So we looked at maize and NDVI data, and in this particular case, so treatments 2 and 3. Where there wasn't a cover crop, showed a higher level of NDVI, which kind of went against with the theory that that we had. And then secondly, that's from this year's trial, hot off the press. So rather than having maize as the following cash crop, in this case, all press farms had leeks as their cash crop. But again, data here isn't very conclusive. You can see that the slight differences that we were seeing at the beginning of the season when looking at leek diameter wasn't very obvious, and it gets diluted as the season goes on. So in conclusion, what we've learned from the trial is that the addition of cover crop treatment does reduce deeper infiltration of nitrogen. So cover crops can really help with mitigating the potential environmental impact of an autumn application of digestate. But with the results that we had from the following cash crop, the data was a bit inconclusive. But as I said, this was only a snapshot that I showed you today. We also looked at soil health and soil structure, as well as digestate acidification. So if you'd like to find out more about that, please do get in touch with me. And finally, I'd just like to finish by thanking Innovative Farmers and AHDB for sponsoring this field lab. And I'd like to thank all our research partners at Niab and Cranfield, and all of the farmers that have been taking part in this project and going along with us on this journey of learning about digestate and cover crops. Thank you.
Thank you so much, Laura. That's Brilliant. And I think the Innovative Farmers Field Lab, it's a really nice setup to pull farmers together and just get a little bit of sort of pilot data to see if something can be tried out, and then, you know, potentially even have a look at it in a bit more detail following. So really nice to hear results of that project. Just seeing if there's a very quick, I don't think there's a simple quick question. So we'll probably, in the interest of time, move on to our next speaker. Thank you, Laura. Don't go away though, because we'll see you again at the end for the question session. So I'm now going to move directly to Graham Taylor, who is going to tell us about an EU-funded project, HyperDense. So this one I alluded to in my introduction, that what happens if you actually think, okay, let's come off the soil entirely and look at an alternative to soil raised produce, and instead looking at perhaps hydroponic raised produce. So Graham spent many years working in Wageningen in the Netherlands. He joined the Niab team a few years ago, and the floor is yours, Graham.
Thanks very much, Lydia. Today I'd like to talk with you a little bit about the EU Interact project called HyperDense, which is something quite different to a number of the other talks that we've just heard, because I'm really focusing on the soilless cultivation of densely grown leafy salad crops. So why leafy salads being the focus in this project? Well, in the UK, there's significant growing demand. If we look at the graphic on the right, it shows over the last 12 years or so, so dating back to 2007, a rapid rise in the value of the UK bagged leafy salad market. If we put some more specific numbers to this, just briefly, back in 2005, the UK bagged salad sector was worth a little over £256 million. At a similar stage, the US sector was worth $1.2 billion. If we fast forward to 2017, the sector had grown substantially, reaching around £1.1 billion in 2017. So that corresponds with a very impressive growth of around 7% per annum. So the sector is growing and growing well. There is some noise in the start, however, just to point out, there is typically celebrity chef and marketing around salads that help sustain demand throughout the year. Although this year, for obvious reasons, this might not be the case. So traditionally, leafy salad production in the UK and much of Western Europe takes place on the soil, so in open field systems. But this is facing a number of challenges which I've touched on before, so I won't dwell too long on these. But these include things like climate change. We just have to think this year alone in the UK, the kind of variable of weather we experienced going from drought to flooding in a very short space of time, which has wreaked havoc on a number of leafy salad growers in the UK, and I'm sure Adam, who's speaking later, will touch on that a bit more. Other threats to the sector linked to climate change, of course, is the ever-growing threat of pest and disease, which is only likely to increase according to pathology forecasts. A further factor stressing the market is the distance in the supply chain. Typically in the UK, production shifts towards Southern Europe and North Africa during the winter months, so around now, and shifts back to field production in the more favorable summer and spring. There's also rising labor and fertilizer costs as an input factor for field-based growing, of course. And there's also growing pressure from the market for a consistent and perfect looking crop. In the case of leafy salad vegetables, yellow coloring on the crop is seen as very undesirable and is not very marketable. A further, more recent issue is the issue of nitrates and human health concerns. Nitrate levels exceeding a certain value are not permitted by the EU for commercial sale due to human health concerns in the belief that it may cause things such as cancer. Now, this really raised its head recently in the Netherlands. Some of you may have seen in the press the last few months to a year ago, a lot of Dutch farmers are protesting nitrate restrictions that have been imposed on them by the Dutch government. So this is likely to be something that might be copied by other European states going forward. So this begs the question, if we can't grow in the field very successfully, or at least without all the challenges that are increasingly becoming common, can we grow another way? Well, one way to do it is through the use of hydroponics, which for those of you who don't know is essentially cultivation without soil. Now, this is by no means a new topic. It's been around for several centuries, in fact, but it was really born out of the need to understand how plants might grow in a controlled environment and the nutritional requirements that they might have had. And then that would help inform growers in a field-based setting. The first commercial operation of hydroponics was started during World War II, interestingly on Midway Island, which is near Hawaii, mostly because the soil was poor quality. And this allowed US servicemen in the Pacific to be supplied with fresh fruits and vegetables more rapidly and more readily. One major advantage of hydroponics that I've touched on is that it allows you to tailor the fertilizer needs of crops more rapidly and more dynamically to support plant development stages, particularly using sophisticated dosing systems that are now available on the market. Typically, hydroponics takes place in an indoor setting, be it a polytunnel or a glasshouse, or an indoor growing facility such as a large warehouse. I'm sure many of you have seen the vertical farming operations that have been widely commercialized in the press. But one major advantage of all this highly controlled environment is that you can monitor the environment very closely and intensively, looking at things that are very important drivers of plant nutrition, such as pH or electrical conductivity. This also opens new opportunities around automation, but perhaps the most salient point of this whole benefit of hydroponics is that it produces less waste. So if you get your nutrient recipes tailored very well, you are able to essentially reduce any waste effluent streams back into the environment. Something that's very hard to do in a soil-based system, of course. So as I mentioned, hydroponics is essentially a soilless culture with just some nutrients that are added to it. But a lot of the time in the past, hydroponics was viewed in such a way that it had to be done in a very sterile environment. So basically creating a plant hospital to eliminate good and bad pathogens, fungi and bacteria and so on. But increasingly in the last 20 years, there's been increasing focus on actually supporting that competition that naturally occurs in a soil-based system. So basically saying, leave the microbiotic components, try and manage the relationship by clever techniques, and also use media that does essentially what soil does, help with aeration, hold the water, and provide a natural means of filtration and a microenvironment for bacteria and fungi to thrive, both good and bad. Now, there is a question mark around the future of hydroponics. At the moment, the organic market is quite small, UK around 10% of the supply chain value. But in the United States, it's quite a different scenario. They have new legislation that meant that hydroponic-based growers can classify their operations as organic. So that's quite an interesting development and perhaps might pave the way for future developments elsewhere. So my main driving point in this talk is really not to view them as competing entities or modes of operation for growers. They can be quite synergistic. So hydroponics, it should be seen as a complementary approach, and it's for two real reasons. It helps you understand the environments in very much detail, so very granular detail, and that knowledge can be then transferred to the field. And it can also help with seasonal production issues. So, for example, as I mentioned, the UK production does shift towards more favorable climates at different times of the year. It could be perhaps employed by a farmer to work alongside the existing open field production system at certain times of the year. So just briefly touching on at high frequency in more detail, we are focusing on three major crop groups, namely rocket, spinach, and lamb's lettuce. And we'll be doing that in a very dense way, as I mentioned, looking at densities of around 400 to 1,200 plants per meter squared. Now, for those of you in the sector, you'll appreciate that those are quite significantly high densities. And that's one of the major benefits, of course, of hydroponics, is that because you eliminate some of the competition elements of growing, you can, by providing a very available nutrient supply, it does help, it does allow you to rather grow plants in a more dense way. So we'll be looking at a number of growth and yield parameters, of course, looking at how to optimize the germination environment, particularly with spinach, which has proven difficult to germinate amongst our partners. We'll be also looking at LEDs as a supplementary lighting source. So looking at how to optimize the LED lighting recipes to support things like color, taste, and growth, of course, and how to improve substrates and ultimately the shelf life of the end product. Finally, just to make it very relevant to growers who are looking to perhaps transition from the soil-based environment to an indoor environment that hydroponics can offer, such as in the polytunnel, we've been partnering with Lockwood Salads, and Adam Lockwood will be talking to you a little bit on his operations later, to try and compare the outcomes of a soil-based system with a polytunnel-based system. And of course, we're trying to understand the economic viability of such an approach by comparing the two systems together. Now, as I alluded to, we have a number of partners across the UK and the western seaboard of Europe. So in the UK, we have partnered with the University of Essex, and Niab, really our focus is on variety section and the LED component of the work. The University of Essex similarly will be focusing on substrate development and the LED lighting. We have two partners in Belgium and the Netherlands, AgriTech and Agro, who will both be looking at crop performance in real hydroponic systems that have been commercialized already. And finally, we'll be having a design team called Harrod in Belgium, who will be looking at how to take all this knowledge that we generate through our various experiments to produce a bespoke hydroponic system, or perhaps even an aeroponic or fogponic variant of it, optimized specifically for leafy salad production. To do this, we'll be using an ebb and flood system, similar to what you can see on the screen there, that little graphic, which is extensively used already. As I mentioned, we'll be looking at also media suitability, particularly in terms of how to mitigate algal development, as well as looking at the sustainability and reusable aspects of media by trying different new and interesting media materials that might take hold in the industry in the future. At Niab, our specific focus, as I mentioned, is on variety suitability, and the reason for this interest in varieties is simply because a lot of the existing breeding programs have focused on soil-based cultivar development and not those based in soilless cultivation systems. So this might lead to new breeding programs once we identify suitable candidates for this. We'll also be looking at how to tailor the nutrients and LED recipes to support plant growth and development, of course. And finally, a real key driver of the whole project is understanding the economic viability of the approach. Finally, just to let you know, north of Cambridge, we have a site in Soham where this will be undertaken, and we'll be developing a pilot system and grow guide as a demonstration point for growers to access and gain a greater understanding and basically have a conversation with us around the benefits and merits of the system as we go forward. So just very briefly, where we're now, as I mentioned, we have a 3-year outlook. We're about a year into that. We've got a polytunnel set up at that site north of Cambridge that I mentioned with Niab. We've had the hydroponic system recently installed, and we have a number of indoor trials underway at the moment under both glass and polytunnel settings, with the possibility to add LED lighting, particularly at this period of the year when lighting is in short supply. Finally, we'll be starting a field trial, as I mentioned, with Adam Lockwood last year. So we're looking forward to some very good comparative results from that. Finally, just to mention that this journey is not going to be easy. Of course, there's going to be a lot of resistance to change in shifting our approaches towards this, but hopefully projects like Harford's can assist farmers considering this is an alternative means or perhaps a complementary means to their operations. And just finally, I'd like to thank a number of the major leading seed suppliers that have supported this project so far with providing seed material. And finally, thank you.
Thank you so much, Graham. Really interesting alternative growing systems going forward, and certainly who would have thought 10 years ago how much momentum they would have gathered. We're going to streak straight on to the next speaker. We're a little tiny bit late now, but hold any questions for Graham until the end. And we're going to therefore move on to Natallia, who is working for PlantWorks as their technical and arable farming lead. Natallia Gulbis has been with them for some time now and has led all sorts of research coming out of this highly innovative technical company based down in Kent. And she has been in particular involved in the smart rotations product development. So over to you, Natallia, to talk about bacterial consortium mixes. And welcome.
Thank you, Lydia. Thank you. I would like to play video for you that was recorded by my... Oh, can you hear me?
Yeah, we can still hear you. We can see your slide, use of bacteria as the first.
Yep. This is the video that was recorded by my colleague, Dr. Julian, and she is talking about our latest trial.
Hello, my name is Julian, Head of Science at PlantWorks. Today we're going to review trial results on the use of our Smart Rotations bacterial product SR3 wheat. The data in the trial we will study are focused on how increasing bacterial activity in the soil can increase nutrient uptake efficiency in plants, supporting a significant reduction in the use of nitrogen. The SR3 bacterial range is the result of 8 years of R&D and over 70 field trials across the UK by both PlantWorks team and major agronomy companies, including Niab. During this time, we have refined the consortia, both in lab, in small-scale trials, and then in large replicated trials. The SR3 products are supplied in boxes containing sterile infusion bags containing bacteria that we have cultured in bioreactors at PlantWorks. The products also contain 1 litre of biostimulant that is supplied as a food source for the bacteria. These products are mixed into standard sprayer and applied as soil drench post-sowing. Building on over 70 field trials in 2019 that showed the direct yield effect of using SR3 on various crops, including cereals and vegetables. In 2020, we sought to quantify the relationship between applied beneficial bacteria and nitrogen use. The winter wheat results we will now review are from a 1,000 hectare Cambridgeshire farm with whom PlantWorks has been working with over 2 years. In this trial, SR3 was applied post-sowing early in spring. The map shows the strip areas in the trial. Each was treated with SR3 and the nitrogen was applied at different rates from the standard 250 kilograms per hectare to 85%, 70% and 55%. Data was obtained from combined readings and correlated using quadrat samples on farm. The picture of the top right shows in detail the trial site with Google satellite image overlay and the coloured areas showing the different treatment areas. Using a sampling technique from the many thousands of data points obtained, we are able to take over 200 replica samples from this data for each treatment plot. It's important to note here that all data presented here is statistically significant. That is to say, the result relates directly to the intervention of the product used. So to the data. Looking at the first bar, we see the negative control with the standard application of nitrogen, but no SR3. This is the lowest yield of all the treatments. The bars to the right of the negative control all had SR3 treatment and had shown better dry yield compared to the untreated control, with 70% of standard application of nitrogen being the optimal yield. Let's look at the data again, but this time showed as a percentage increase of dry yield over the untreated control. We see an increase at 100% nitrogen with 6% increase in yield compared to the untreated control when SR3 had been used. So what we are seeing here is the crop becoming more efficient at using the nitrogen applied when the bacterial community is stimulated. Again, the maximum effect is seen at 70% of standard nitrogen rate with an increase of 16% over the negative control. Let us review for a moment the profitability of the treatments. Here we have taken actual farm costs, including the spray and the SR3 product costs, and shown the maximum profit treatment. Although the maximum yield point was with the 70% of the standard nitrogen treatment, although only marginally, but the maximum profit yield came from a reduction to 55% of standard nitrogen. So in conclusion, if you are farming for a maximum profit by increasing your crop nutrient uptake efficiency, by increasing the beneficial nitrogen fixing bacteria in the soil, you can significantly reduce the cost of achieving yield. In addition to treating winter wheat at the Cambridgeshire site, we also treated the spring wheat. The site used for this treatment had been previously treated with SR2 mycorrhizal fungi as part of the long-term treatment to increase the baseline biology of the field. The spring wheat nitrogen variants range from 100% to 70%. Again, data was obtained from combine readings, and this data was validated against quadrat samples on site. Again, as before, we can see all treatment plots increased yield over the non-treated control, and all results were statistically significant. In the data shown here, we see the maximum yield point was at 100% nitrogen application. We can postulate here that the plant's demand for nitrogen was high, and it increased uptake efficiency supports higher grain development due to the application of SR3. Again, showing as before, this data as percentage of the increase in dry yield compared to the untreated control, we see a similar maximum yield increase as with winter wheat at 16%. The trend in spring wheat is clearly different from that seen at winter wheat, which may not be surprising when you consider the demands on the crops and soil interactions from spring wheat over winter wheat. We'll conclude again that all treatments have shown a grain yield increase through increased nutrient uptake efficiency through the increase in soil biology. The profit review is interesting again. We see that due to the 16% yield point increase at the 100% of nitrogen input, this is the maximum profit point. It's worth pointing out though that with the progressive reduction in nitrogen in the other treatments, this resulted in a fairly consistent profit uplift over the control between £40 to £70 a hectare. So just to summarise, these trials have shown SR3 applied areas had higher dry grain yields for both winter and spring wheat. SR3 application compensated for lower yield under lower nitrogen input in wheat, and SR3 application can improve the profit of wheat crops for growers. We'd like to thank you all for listening.
Thank you very much. Just a quick, again, summary from me. That is results of 8 years work, and other scientists also tested our products, including Dr. Saeed Shah from Niab, and we are glad to report that his data correlates with our data. And if somebody would like to buy, product is available for buying for your application in spring. Thank you very much, Lydia.
Brilliant. Thank you, Natalia, and Q as well.
Yes.
Don't go away. We're running a teensy bit late, so we're going to shoot straight on to the next speaker, but don't go away and hold questions for the PlantWorks team till the end. So David, you're next up. David Harrod joins us from Payne Crop Nutrition. Payne Crop Nutrition started up as 2017. However, don't think that he is a new boy on this particular block. David has been working in crop nutrition, fertilizer blending for about 4 decades, but he's going to tell us about some innovations that he's been working on quite recently. over to you, David.
Well, welcome everybody, and hope you enjoy the next 6 minutes of my circular economy journey. Happy to share this with you. My name is David Harrod, and I'm with Payne Crop Nutrition. I'm going to present to you over the next 6 minutes or 5 minutes, recycling waste minerals, providing sustainable crop nutrition. And I hope ongoing from that, it will stimulate some positive discussion. So please hold on tight and imagine. So I'm just going to connect you quickly to my take on the circular economy, which is what we're involved with. We want to look to design out waste and design out pollution, keep products and materials in use, regenerate sustainable natural systems, and the great thing for the planet will be lowering carbon footprint. This is a part of TraceGrow's vision from Finland, which is the company I'm working with. And this is our circle of life. I'm not going to just dwell on this slide just at the moment, because you can all take a look at it in your own time. But I'm going to take you through for a couple of minutes. What are the big issues to do with this poor little, seem to have a there we go. This poor little humble alkaline battery. What's this ever done against us? Okay. Well, believe it or not, 10 billion alkaline batteries a year are used globally. I'll bring that right down to local. 660 million little alkaline batteries are used in the UK alone. That's about 40,000 tons. And what it's doing to make those batteries, we're using finite global natural resources, zinc and manganese. You can see from my picture at the top there, are being mined all around the world to be turned into these alkaline batteries, which die after about 100 hours. So in Europe, alkaline batteries are banned from landfill because if they go into the water courses, like I've got a little picture there, ecological issues such as eutrophication of lakes and river courses, etc. We don't want that to happen to us. It's bad for human beings and it's bad for livestock. One little alkaline battery, for example, data tells us can contaminate 167,000 litres of drinking water. That is a fact backed up by data. But what we're going to do about this? Well, carbon neutral by 2050 is our new strategy from the UK government, and we're all encouraged to take part in that. So recycling is now a key strategy. EU regulation 2066, battery recycling. Today, across Europe, we are encouraged to recycle 45% of these little beauties. In the UK, we are now achieving 45%. About 18,000 tonne of batteries a year we're recycling in the UK. What are we doing with them? Not a lot. They're mainly going into storage boxes. Some are going to industrial smelters, etc. Going into industrial smelters, they're giving off fumes as well, okay, into the atmosphere. So a good thing, a positive thing about this issue is the general public across the UK and us here in the UK, we're encouraged to dispose of these little batteries into the recycling bins at supermarket shops, places of work, local recycling centres, the supermarket. You've all seen them, right? They go into the little bins at the top there. They go into storage. Big issues going forward. Batteries, these alkaline batteries are going up in global demand by approximately 6% a year. So alkaline batteries are not going away. We're stuck with them. We've got to reuse them. Okay, so I'm going to take you on to one of our solutions. This is just one solution globally, which is unique at the moment to TraceGrow of Finland. So here we go. This is one solution in the world, okay? So we take the batteries at the top here. You can see the batteries, recognize them. They are crushed by a recycler. We at Trace Grow take what we call the mixed metal dust or black mass known in the industry. It's full of around about 80% is full of manganese and zinc. Okay, but what is also in there is chromium, nickel, cadmium, all sorts of stuff. Please, any farmers listening on here, do not put this on your soils. It is a bad thing to put on the soils. So what we're doing, we are then taking it for a patented process in Finland, purifying it, filtering it, cleaning it down. As you can see, it's a dark blacky type of material, okay, which we are purifying into a very clean product. Does it exist? Yes, it does. Here's some here. It is in the market in the UK and Ireland, comes from Finland. So once we have the purified product, this is a part of the circular economy. Here's the factory in Finland. We are then turning it into this clean product in 10-litre, 1,000-litre cans in the UK. We're working with research stations like Niab, etc., in the UK, where we are carrying out efficiency tests on, does it stay in the leaves? Is it creating an environment to increase yield? It's a part of a balanced nutrition system to put manganese and zinc, all sulfate based, onto a crop. It's also in Europe, falls under EU regulation 889/2008 for organic use. But let's not forget conventional farming systems as well. So our big strategy here is to lower carbon emissions. And we're doing this by the raw materials. The raw materials are not virgin raw materials. They are second life circular economy. So we're starting off with a zero carbon footprint on our raw materials. We're then working on what's our production footprint and then what are our logistics footprint. These are lowering carbon footprint numbers that we're working on today. Okay, this is just one solution. And I'm going to finish off my final slide, if I can get it to work. Here we go. So the product label is here. So you can, it tells you we have zinc in there, we have manganese, and we have zinc. Sorry, sulfur. We're testing out some trials this year with Niab. These are tissue test analysis, just to make sure the product does stay into the leaves for its sulfate based and is not washed off. And then in Finland, where the factory is, you can see there's some yield data of 23%. Yeah, that was a good year. This year the trials haven't been so good because of the conditions for the harvest. Here's a farm just outside our motherland of Cambridge. You can see some differences in actually a farmer using it in the lighter areas versus where he didn't put it in the darker areas. So this is just some of the ongoing trial work that we are working on today. So I think that's virtually wrapped up. I look forward to some nice healthy questions under the Q&A session, and follow us on Twitter and enjoy our journey. Hopefully you'll all take part in it one day. Thank you, Lydia.
Brilliant. Thank you, David. When I first heard about this not that long ago, I found it a really exciting, really nice demonstration of circular economy. So thank you for that rush through, and I think we'll hear more about that in future. I look forward to questions, but not yet. Hold your questions. We have last but absolutely not least, and as I said, it's always vital to go back to the farmer. So like the first session, we're ending our second session with a farmer, a really innovative young farmer who has set up his production very recently, but is really going places. He's got 90 hectares of baby spinach, red chard, red rocket, etc. And I'd just like to give him the opportunity now to share what he's doing in this leafy salad area.
Thank you, Lydia. Thank you for that. I'll go quick because I know we're all thinking about lunch now, so we'll crack on. So just a little bit of a background on us. This is our story. As Lydia said, we're very newly established. So it's my partner and myself. We set up. I'm tired of working for people. So that's a crazy idea to set up our own farm. So we're growing baby leaf salads, as mentioned. So spinach, chard, bulls with rocket, cress and stuff, the kind of stuff you buy in a mixed bag on the shelf. We supply retail, food service and wholesale markets. So we've got our own branded stuff on a very modest on-farm pack house that we supply local outlets, which has obviously been affected this year with the virus. But we also do retailing directly. We've got 90 hectares of rented land based in Leicestershire on the Leicestershire-Warwickshire border. And we produce about 30,000 kilos of salad a week. So yeah, it equates to about 150,000 bags. So it's quite a lot of leaf really in the scheme of things. So just a little bit about our farm. Obviously it's all rented land. So we're renting from a large farm that grow a lot of different crops, including root veg and beet and potatoes and carrots and parsnips. We just kind of slot in as and when we can fit in with them. The soil is light, it's boys' land, as my family always say. We've got it easy. It's silty, sandy, loamy soils, which are really nice. They hold a bit of moisture, but they're easy to work. So for our kind of intense production system, it works really well. Quite full on. I'm tired. It's the end of our season now, our second season. So we start in February, end of February, start drilling, and then it's a constant process. So we're drilling 2 or 3 times a week. And harvesting is from the end of April, and we're harvesting every day. We're harvesting product every day to order up until now. So we're finishing this week. 30-day growth cycle of the majority of the crop. So it's quite intense. So the easy thing is to kind of put as much in and get as much out as possible. Isn't always the right thing. So we can triple crop within the summer season, but it's not always the correct thing to do, as we'll see in a minute. So back to the soil, mainly soil related, but not all. There's a lot of different aspects, a lot of different challenges and issues we have. I could talk to you all day about the problems we're facing. It's very difficult, it's very hard, it's becoming harder. You can see some of the key issues here that we've got. That picture on the left, so that should be red. That's a bed of bull's blood, which is a red salad crop. It should look red, not like that. Weeds are becoming ever more of a problem. Even within this season alone, we've lost two herbicides that we were allowed to use. They're no longer legal. We're left with one that we can only use a third of the rates we could 2 years ago. So we're having to really think outside the box and look at different things and different options on that to avoid hand weeding and the frighteningly expensive cost of that. Lots of other things really, I won't dwell on it too much, but soil-borne diseases in the top. You can see with the Pythium there and some damping off, massively impacting your yield. Some compaction, that spinach there, you can see slight variation across the bed, just some yellow lines and some greener bits. It's that variation that is also a problem, which we'll talk about how that impacts us. So waterlogging, you see, the problem with our operation is we're having to do it every day to order. So we can't ring Mr. Tesco and say we can't cut today. We have to go out there and do it. So we're facing these kind of challenges, which again, we'll touch on a bit later. So yeah, all of those issues that we're facing, it's how that's impacting us. You know, again, soil quality, I always say the soil is key to everything we do. If we get that initial bed forming correct, everything kind of follows on from there. If that's wrong, we're on the back foot from the beginning and it's just expensive. You know, the quality is always going to be reduced. The yields are always going to be reduced, which will obviously end up in rejections, loss of sales, customers not happy, you know, there's difficult phone calls. And of course, you know, people don't talk about it, but it's an unhappy workforce. So it creates a lot of issues. You know, if you're going to have to go out there and weed all day in the rat, it's just very difficult, very challenging. So it has a massive impact on our business, both financial and in terms of what we, you know, the impact on the soil. But I think one of the key things is we've talked about a lot of good things we can do, but it's important to stress this. And I think this is where there needs to be a lot more focus on education of consumers on challenges that we're facing really. Luckily, none of these pictures are actually on our farm. They're from previous employers. We don't tell them that I've stolen those. But we do get scenes like this. We try and avoid it the best we can. But when Mr. Tesco wants his spinach this afternoon, he wants it this afternoon. It's too wet, Mr. Tesco, we can't do it. You do that, you lose your business. So I think it's very important that we start to look at educating the consumer much more and giving them a real, you know, idea of how challenging and how difficult it is and the impact that we're having on our soils and our ground and how, you know, it's easy to do that now, go out there, but that's going to affect the next crop that we put in and it's just going to elongate the issue. So And then just a list of things there. They want perfect leaves, they want perfect colour, they want perfect size with no damage. They don't want soil on their leaves, they don't want stones, contaminants, and bacteria is a big problem as well. So it's a big list that they're kind of wanting us to meet, really. And yeah, I think it's important that education is pushed onto them, really. So there's some of the challenges, kind of what we can do and what we are doing to try and help with that, really, on a day-to-day kind of practical basis. Obviously, field selection is key. We're quite limited. Again, as a small business, we don't have funds to throw at this, really. We don't have access to a massive amount of land. And as I say, we are slotting into another rotation. So we kind of to a degree go where we're told. So within that selection, we have to pick the lighter soils for the early and late periods and the kind of, the high pressure periods of rain, which is becoming ever more hard to plan. Technologies and stuff, it's advancing quickly. We've got to get on it. It's expensive. It's the future. We need it. There's a lot coming along, but still lots of work to do. We mentioned earlier about robots and stuff, and that's what we're focusing on. But it's just we need to really look at the costings there and how we can get involved. Crop rotation again is really key. We saw some of the soil-borne diseases there that we've been struggling with, and yeah, just making sure that we're widening that as much as possible and getting as much different things to improve the soil structure, to prevent crossover and contamination of disease and all that kind of stuff, which we work closely with our landlords on to try and achieve that. Also, various different things we're doing, crop covers and stuff to reduce pesticides and fertilizer. It's not directly, linked to soil, but it is in a way. Stale seed beds, making sure that we're working ground when the conditions are at their optimum, and kind of that's helping with lots of different things, really, weed control and all sorts. Again, making sure the seed bed's right, which will just, make the process much easier, much better, and increase yields and outputs. Equipment a little bit there, just we very much focus on small equipment. We're not using heavy tractors. Our tractors are all less than 100 horsepower compared to some of the monsters you see out in the fields at the moment. That's nothing. So, and that's how we want to stay. I think that's important that we stay like that. And gathering data and weather information. That station you see there, it's a Davis system that we use. It's a fantastic system. It's got soil moisture probes, temperature, it tells you everything. It's amazing what it can tell you, and that's key in making sure we're doing the right thing at the right time to have minimal impact on the soil, really. So just to mention here as well, because one of our big pressures is, it's that balance between doing what we can for the soil whilst meeting the customer's demands. And there's a lot of risk in what we're doing. So bagged salads is high risk. You've all heard in the news, E. coli, Listeria, Salmonella, it's a serious problem. So there's a lot of things that we would love to do, but we can't do, so having livestock and slurries and manures and stuff in the rotation is just impossible. So we've got to really think outside the box to try and get that balance between intensely farming stuff, making sure our produce is safe, and, kind of integrating some of these systems as well. Like over encouraging natural predators, it would be wonderful to have beetle banks up and down the field. We'd love it, wildflower mixes, but Mr. Tesco and the consumer, the general public, do not like ladybirds in their mixed bag salads. So it's just constantly finding that balance, and I think that's as an industry we really need to work on that. As Graham mentioned earlier, we're working with Niab on some trials. I think really looking forward, I think this is the future. I think this is the solution. Obviously not to this scale, but on a serious scale. And I think it's the only way we're going to really be able to kind of safely produce food consistently. It's okay to get fantastic yields, perfect quality 1 week out of the year, but we need to be able to do it week in, week out to make sure that we're feeding the world, really, whilst having minimum impacts and just having the control of it. So I do believe this is the future. We just need a massive pot of money to get into it, but I'm sure that will come one day. I'm sure we just keep going. So yeah, so there you go. Thank you for listening. Anyway, that's a little bit about what we do and how we're trying to do our bit, really. So
thank you so much, Adam. Always, in my view, important to bring us down to earth, if you excuse the pun, with the farmer outcomes. And yeah, you know, a lot of things there to consider if you want to have potential solutions. It's vital to realize what the constraints are on farmers in terms of inputs and in terms of when you choose to get your outputs. Very tricky if your retail partner is stamping their foot, you have to deal with that. We're a little bit over time, so obviously members of the audience, thank you so much for being with us. If you want to dash off now, I won't blame you. I don't want to lose the chance of asking one or two questions. We've got some really interesting questions, but if I can ask you to be short, so that we can get as many in as possible. So if we aim to go on for another 2 or 3 minutes, that would be brilliant. So the first one that I see, which is a really quick one, which is for David. I saw it a moment ago. It was basically along the lines of, wouldn't battery makers be keen to interact with you in order to save money with dealing with the waste? I can't find the question, but I read it earlier.
Okay, yeah, I did. Thanks, Lydia. That's a great question, and one that is not going to be totally answered today. But what we do in Finland, we take a gate fee is paid because the battery waste is a waste. So the factory does take it and gets paid a gate fee, like any waste recycler into the factory. Going up the value chain to battery manufacturers at the moment is an ongoing global discussion, which no doubt will come up. Okay, at the moment, they're not paying anything on the table, but no doubt going forward, that discussion is going to be opened. Okay, but it's a very good relevant question. Hope that shortly.
Thank you. Thank you, David. I have a question for our last speaker. It's a big question, so I'm going to ask you to be brief. I don't know how you're going to manage that, but I think it's worth airing the question. Educating consumers is very important, but as you've mentioned, the supermarkets don't allow flexibility to account for environmental conditions. What do you think is the solution to this? Consumer pressure, government intervention, tapping into local supermarkets, or what?
That's a tough one, isn't it? It's just, yeah, hard to say. I just think we've really got to, we've got to get people, things like Open Farm Sunday, fantastic. Get people out on farm, get people seeing the challenges we're doing, get it all in, you know, at an early age, get it into schools, get people educated, you know. It's frightening how many people don't believe, you know, but you go, you know, you talk to people about where food comes from, they haven't got a clue. And I just think it's got to start at an early age. It's got to be, like I say, get people on site, get people on farm. And farmers as well. I think we're guilty of kind of keeping to ourselves. We're a bit competitive, you know, the industry is quite small. Nobody works together. We've got to come up with a solution as an industry, really, and communicate, you know. I think that's key.
I agree. I've got a question here, a quickie for Natallia. What bacteria genera were used in your trials, and have you tried this in oilseed rape?
Okay, thank you. We used bacteria from 4 different genera: Bacillus, Agrobacterium, Gluconacetobacter, and Derxia. On oilseed rape, we have a different composition of bacteria because we discovered that not all bacteria is suitable for all crops. Therefore, for oilseed rape, we have, again, 4 different genera. And I think is only common is Gluconacetobacter. So for oilseed rape, it's a different product.
Thank you. And I have a question for Graham. What would be the implications to the amount of land used if more leafy salad crops were produced via hydroponic? Would there be a vast reduction in the land need for production or marginal differences? Bit of a tricky one because you're not a farmer, but you know, we'll have a go at that one.
Yeah, that's a good question. And I think it's one of the key output information streams that we hope to get from the High Fidence project. It depends on a number of different factors. Obviously, different crops are more conducive to growing more densely and vertically stackable, such as rocket, compared to, say, things like Swiss chard or spinach, particularly if you grow them to a longer development stage. So that's one of the key things we're looking at. And I think it can be significantly reduced if we go vertical, if there's the economics back that, and obviously if there's traction and appetite from farmers to do so. And
Laura, a quick one for you. Thank you, Graham. if the cover crop is ploughed in, does the nitrogen in the crop then get used by microbes to help compost it down? Have a go at that one. I know it's not quite what we were doing in the project, but what are your thoughts?
Yeah, I mean, that is definitely something that would naturally happen, and that's why we chose a range of cover crops that would, you know, break down into the soil at different times of the growing season, so you can spread that out. So yes, that does happen, although it's not something we specifically measured as part of the trial.
Thank you. Since we are now properly over time, I think we should probably wrap up. Thank you so much for all the speakers, and thank you for the second set. That was a really nice look round all sorts of possible innovative stuff that's bubbling up in the industrial and the farmer communities. So really looking forward to see how they continue to develop. There are one or two answers to questions. If you look in the questions, and in particular, for example, there were questions about humic acid earlier, and there's some interesting references that somebody's put there, so you might want to have a look. One final comment. This is being recorded. So one farmer said, I was out carving. Can I see the beginning, which I missed? So we have recorded it, and subject to the speakers being happy, that will be available for the most part. And finally, thank you, Agri-Tech E, for letting us join your Agri-Tech week, albeit at home, semi for some of us. Hope to see you all again soon. Goodbye and have a lovely afternoon.